Hello everyone, I'm Riccardo Bassoli. I'm a W1 professor at TU Dresden working on integration of quantum technologies and 6G.
Hello again, everyone. I'm Stefano Buzzi. I work at the University of Cassino in Italy, and I work on physical layer technologies, mainly for wireless networks.
Hi, I'm Mohammad Soleymani. I work at the University of Paderborn. My topic is race-aided communications, optimizations, and multi-user MIMO.
Yeah, I'm Sándor Fekete. I'm not sure if you've met before. You may have heard of my work someplace before. I work at TU Braunschweig and do a number of things with many interesting people.
Okay, I can talk here with my phone, so I just have to switch it on. So I'm Marc Geitz. You know me maybe from yesterday night, if you've been there. So I'm working for Deutsche Telekom, from a network provider. So you're now in the lucky or unlucky situation that you have somebody from practice leading this panel. And when I read about networks, I actually prepared a teaser, which is in the making. So I have to. Okay. I thought we'd talk about today. I hope you agree, yeah, because we didn't contact before. I didn't know you. I didn't know your topic, research topics. Yeah, so I actually learned myself by looking at the agenda yesterday evening that I have to chair this panel today. I thought we touch security, yeah, because security is part of the conference. Yeah, if we go on, we can talk about AI and networks. Yeah. Because maybe came a little bit short, and there's a lot going on in China. And if there's still time, we can talk about quantum and networks. I'm coming from practice, right? And there's a big security department working with my company, yeah, so several hundred people. And I just try to give you an idea what they do the entire day. Yeah, and there was a new project where this screen has been invented or created from. It's called Sicherheitstacho.eu. Yeah, everybody can look at it. And what you see is what's happening in our network, the telecom network worldwide just now. Yeah. So what they do is they have honeypots. Yeah, several hundred of them. They are sitting in a network. They're attracting attackers. And I just wanted to show you and have a look at the numbers. Yeah, you see the big number. It says 125,149 alarms in 60 seconds. This is what's going on. Yeah, so 125,000 attack attempts in global communication networks in 60 seconds. Yeah, and on the lower side, you see what is actually happening. Yeah, and they try to get into file sharing services like Samba, remote administration. You see the Dutch are number one at the time being, yeah, with 600,000 attempts in February. Yeah, targets mostly Germany on the top because we're a German network provider. And here you see the alarm feed, what's happening just now at the time being. Yeah, you see port scans, attacks on Samba servers, and all that kind of stuff. This is reality. Yeah, and I'm showing you that because this is what also research community think about. Yeah, what can we do against that when we design future networks like 6G? Yeah, can we put something in? Yeah, that helps stuff to do stuff against it. Yeah. So there are 500 people working in that field. Yeah. I also prepared a slide, but I think I'm not waiting for that now. The number one attack vector, yeah, in these networks is theft of identity. Yeah? So my company has this database of, I think, 50 billion identity records. Yeah, they got out of the darknet from our customers worldwide. Yeah? And there's really a big number of people just screening that, yeah, and telling customers, oh, come on, you have a problem. Yeah? And this is what you can do. If you ever got an email from Deutsche Telekom, if you're our customer, I don't know, this happens really quite often. So identity theft. The other one is system vulnerability. Yeah? So in principle, I can always say, patch your systems, your stuff. On the slide, it was S ... means also your shit. Yeah? we are having 6,000 servers out there, yeah, that are facing the internet. Yeah? And if there's a single vulnerability on one of the servers, the attacker is in. Yeah, and then we have to manage that somehow, yeah, to squeeze them out, build resilient networks. Yeah? And the number of vulnerabilities, I mean, this was also amazingly high. So per day, recorded by BSI, thousands. It's really amazing, yeah, what's happening out there. Yeah, it's really a big issue. And this is our pain point number one. So I'm telling this, maybe now to you, the panelists. Sorry for that. Yeah, this is what's happening and what's addressing industry, yeah, by running these networks in the security area. It's not cryptography. Yeah, it will maybe become cryptography in the future. It's just theft of identity. It's system integrity, stuff like that. Maybe we start discussing on that now. What do you think about your research? And I'm happy that you're here, Riccardo, because you're working with 6G. Yeah. It's a teaser. Maybe we can start, maybe also the audience can comment. Yeah.
Okay, so the topic is quite interesting. And the problem is multidimensional, I would say. So in 6G, we target trustworthiness. That is not only security, privacy, but you have to trust the network. And data are not normally in one place. Maybe they are stored for resilience in different data centers. And currently, even if they are stored securely, the last attacks on AWS and Google showed it. It's a matter of time that they can be accessed. So the results on homomorphic encryption, let's say, never became commercial as far as I know. And maybe I can talk for the quantum area. Maybe blind computing based on quantum computing or like quantum technologies might help on that. But then there are different levels of attacks. So not only accessing the information, but making it unavailable. So if there are millions of AI agents automated attacking single points, now is like very feasible. So how operator network can react on such a level of traffic that maybe in 1 millisecond attacks millions of nodes or thousands of nodes. So these are scenarios in which I think the discussion of 6G might not be prepared. And maybe even our scientific community is not considering so much this level of threat. So this just to connect to what you said.
Okay, just a disclaimer, I work on wireless communications, so physical layer, MAC layer, so I'm not really an expert of these things, but of course they are very, very important. And at the physical layer, there is a line of research that regards wireless physical layer security, where we try to grant security and just at the physical layer. So adding just exploiting the physics and adding a further layer to the security. But still, I mean, this is a problem that is to be considered, and there is not only this type of the wireless level. There is the problem of jamming, that spoofing attacks. So I mean, it's a serious problem, and I think that also given the geopolitical situation, there will be. I mean, we will see more and more of these attacks in the future. Of course, as Riccardo says, we need to try to bring resilience and security as a design guidelines for designing networks. Usually, but I mean, at the moment, I mean, there is not much of the. this discussion in 3GPP, at least regarding to the wireless, from the wireless point of view. This is something that so far has always been relegated to higher layers of the networks. But I mean, this is something that we have to think about also. At some point, probably we should also try to introduce security and by design also to the physical layer, just to add another layer of shield against these types of attacks. By the way, if I can do, I have a question, a curiosity. I don't see any attack coming from Russia. If I
Yeah, these are, let's say, our networks. Maybe we have no networks in Russia. Yeah, this would be the answer, right?
Okay, that's the implication.
Yeah.
Okay.
Maybe they are, I don't know, so I have to scroll down.
So my also research area is more related to Stefano. So I work on mainly physical layer. So the physical layer security would be maybe a bit different from the network layer. So from physical layer point of view, we can work on maybe securing the access of the users to the network. So maybe adding more authentication, or also considering more security metrics. So one would be from information theory point of view, considering the secrecy rate. Yes, in line with what I also presented for multi-objective optimization. So we mainly see, especially from the physical layer point of view, performance metrics not related directly to the security. So I think it needs more attention also from not, handling it at higher layers, maybe focusing more from both physical and mic layer would be challenging, and maybe it can be one of the future research lines that I am currently missing in the discussions of 6G from the physical layer point of view.
Yeah, thank you. So as I mentioned before, I'm not a networks person. I'm not a 6G person. I'm in algorithms, and I'm also not in security. So that's a bit of a, scientifically, that's a bit of a denial of service attack that you're launching on us here. But let me just still try to address that. Because when you are building large distributed systems with many, many agents, one tends to think of the system as like a beehive or an ant colony, and a lot of things work. You just put these things together and they cooperate and do all this. But an important part is when you're looking at as a metaphor for your network, you're looking at a beehive or an ant colony. Everybody's on the same team. And it doesn't make sense for an ant worker to cheat on the team, or for a bee to try to topple the queen or something like this. And that's really important to keep in mind when we build artificial systems. So let me take you back to this metaphor or this application of traffic, because this is something where we all have some experience. Not network traffic, but physical traffic with vehicles. And you have all experienced this. We humans are actually very, very good at cooperating. And not just cooperating because we're all nice and we sing songs and hold hands and all this, but we're still cooperating in the face of adversarial agents. There's wars, yeah, but the thing that makes humans really, really good and successful is not just our supreme intelligence, but our ability to cooperate. Even if we don't necessarily all belong to the same team. So over hundreds of thousands of years, humans have developed a large array of mechanisms to cooperate, even with self-interest. So when now you consider driving through traffic, what makes that very different from an ant colony or a beehive is that in traffic, people don't belong to the same team. They have their own self-interest. And you have faced this, that you go through this and people are nice, or sometimes people are nasty and try to cut in and do nasty things and so on. Usually they don't try to push you off the road, to get a clear way and all this. But we all understand this frustration, and we're trying to be good citizens in traffic, and then something bad happens. Oftentimes, this is an issue of limited interaction, establishing cooperation, all these mechanisms that we have, making eye contact. By the way, humans have this very, very powerful device called wide eyeballs, which make it really very easy. Most primates don't have this. If gorillas want to make eye contact, it's much harder because they have dark eyeballs. So when you're in traffic, you encounter these limitations of establishing cooperation. And this is really, really important, because the frustrations we feel, if you put yourself on a densely populated highway, and we have seen this, and on German highways you're not allowed to pass on the right, so traffic gets denser, and you cannot pass on the right. If you want to go faster, you have to be on the left. So what happens is that everybody goes to the left lane, and then there's 90% traffic on the left lane and only 10% on the right lane. It's really frustrating because traffic, boom, does this, called prisoner's dilemma. So this is an instance of the prisoner's dilemma, not cooperation and so on, so on. So when we build artificial system, and then I should not turn this from an answer to a talk, when we build these artificial systems, we should keep an eye on what humans are doing to maintain cooperation and protect cooperation against adversarial agents, and analyze this a lot better. And economists are really terrible at this, because they say greed is good and so on, and be selfish, it's great. So every complex system of agents with many different interests needs something which is an immune system. I mean, this is sort of immune system, like molecular or cellular level and so on, but higher level incentive structures as well, which is what humans have been working on for a long, long, long time. And if we don't do this in the big complex systems we work on, if we don't integrate some rules which support cooperation beyond just immune system, then we will be very surprised if some entrepreneurs will program Waymo taxis to waylay highway traffic and say, like, for a small fee, we'll let you pass.
So what I understand in principle is you say collaboration between network and user to prevent identity theft.
I guess you're mapping
I'm trying to map this on my
Yeah.
question. Yeah, so identity theft
Sure.
and system integrity. Yeah, so I mean, this could be actually a good solution. Yeah, so it goes into semantics a little bit. Yeah, so you learn how the user speaks, types, works, what process he's doing in order to identify him better, and then you just get away from simple two-factor authentication or something. Yeah, and don't know.
I guess we have to be mindful of mechanisms in the systems we build, which, if you build it up from basically the molecular level, then don't be surprised if there's some higher level emergent behavior. I was showing a hurricane earlier, which you didn't foresee, but which you should look at from a higher level point of view. Like, how do we get cooperation? So maybe there's a separate discussion about, like, having community rules that reward unselfish behavior and that make it worthwhile. And there's a separate panel discussion on this.
Yes, a separate one. Yeah.
Yeah.
Is there any comment from the audience on that? Please, yeah. Have a second mic or no? Yeah, here he is.
Well, thanks. Yeah, I fully agree with you, right? But I'm really excited about seeing in the long-term vision here how we develop our networks in this kind of cooperative, more mindfulness, sense-making, and all these kind of ideas we do have maybe in the future. But when it comes to the 6G, and 6G is quite soon approaching somehow, right? I have the question to the Deutsche Telekom. because
turn it around.
since yeah, exactly, yeah. I turn it a little bit around. I'm sorry for that, doing that. But nevertheless, because anyway, we will have some works to be done, right? And we will do that in the 6G time of a framework here when it comes to cybersecurity issues. The key question is now, can Deutsche Telekom help in order to streamline that kind of a work? That means we see this number here, but how impactful are the attacks? We will have maybe some attacks which are less impactful on the network. Sure. Some are more impactful. That means in order streamlining the work we need to be done to make 6G more cyber secure, it would be good to get some indication by operators like you guys, right? Giving us some, this is cool doing that, it's important, and this is less important. Because I see a kind of, let me say, how should I say that? Maybe we're doing the wrong thing at the end of the day. So that means to be really streamlined in the sense that we make 6G high secure. It would be good as an indication of the impactfulness of these attacks here. We see maybe a large number, but maybe only 10 attacks are really impactful out of these 160,000.
Yeah, at the end of the day, you don't want to have any of these having
yeah,
impact,
for
right?
sure,
That's
but you know what I mean? We cannot do
yeah,
everything at all once.
Sure, but that's what I'm doing now, right? I mean, this was actually the intention of bringing this story, yeah? Because I'm pretty much aware there are not so many people of you knowing that. Yeah?
But I have seen the BSA has done some kind of study of the networks, right? And I was at a conference where the BSI guys presented exactly a kind of list. What are really the most critical attacks, the less ones? I'm not sure if these guys have the full picture. So it would be good that, is there anything going in that direction?
I mean, if my colleague would now stand here, he would give you the entire story of what's going on. Yeah. So, I mean, the biggest point at the end of the day is you want to prevent the attacker to get, let's say, root access to your servers. Yeah. I mean, we really take into account they're in. Yeah. They're in. Yeah. You have to accept this. Yeah. On most of the servers, there is an attacker. Yeah. But you have to prevent him from getting further. Yeah, I mean, all the attacks on the Zamba servers, it's a very insecure file sharing technology. I mean, there are exploits known. Yeah, I mean, you can try them afterwards and you're in. But then you have to, in principle, prevent the attacker from going further. But once you're in, cryptography, post-quantum cryptography, physical layer security doesn't help. They go with the channel because they're in. Yeah, they're already in the system. Yeah, so it's cool that we research on that. And once quantum computers can hack cryptography, that's going to be a bigger problem. Yeah, then maybe we stand here with a different chart. Yeah, but at the time being, it's really no issue. Yeah, so cryptography is solved in principle. From you know what I want to say.
That's
it's not so,
exactly what I expect.
Yeah, and. When I come from these conferences, I give reports, and then I get the questions. I mean, that's all cool what you tell us, but it doesn't help our problems, right? And that is in principle why now I'm a quantum guy. I'm doing quantum networks, and that's why we're not building large-scale quantum networks, because the killer use case is somehow not apparent. And to bridge the gap, I thought I misused this panel. And thank you for giving it a try. Shall we change topic? Yeah, I'm the chair, so we have 7 more minutes. I want to talk about AI. I visited Globecom in December, and I heard all these talks from the Chinese about AI and 6G, and it was really astonishing for me because I was not so deep in. So there's AI edge, there is spectrum optimization with AI, there is full stack AI, self-healing networks with AI. They're talking about intents. So we don't do TCP/IP anymore. So there's a new data kind of they call intent, which is probably based on IP, TCP/IP. But it's not anymore, And then I just remember this final statement of that Huawei guy, He said, iOS is dead, Android is dead, TCP/IP is dead, the internet is dead as we know it. I was like, okay. I don't know. I actually just wanted to make this a question, a teaser. Yeah, it's again 6G. I'm sorry, but I'm from Telecom. What do you think about that? You have an opinion? Oh, sorry. Yeah. Yeah. Mm.
So you're throwing these very general questions at us. You have to live with getting very general answers.
It's okay. So,
possibly
yeah, it's a discussion.
So
right?
I'm a computer scientist, as I mentioned, and my chair is called algorithmics. So you can imagine that algorithms and AI is somewhat related. What I have seen, observed in other contexts as well. Let me give you a very specific context where that should illustrate that we as scientists need to be mindful not just of all these possibilities and all how things are dead and so on, but against magical thinking. So magical thinking is coming back from the dead. That's sort of the other way. So in this context, so I've had this this project on climate change for 4 years now, more specifically in extreme water events. So we've all seen this in recent years. There are these heavy rain events. You pour, in short time, massive amounts of water over the landscape, whether it's Atal, or it's the desert, or somewhere in Spain, or in West Texas, and so on. And then these things happen, and usually they're very unpleasant and very undesired. Now, they're very hard to predict because a weather forecast, I mean, it's the prototypical chaotic system. The butterfly effect from 57 comes from meteorology. So we have chaotic input. And then we have some things that happen when this event occurs. And that is not completely chaotic. So if you pour massive amounts of water over some landscape, it's not random what happens. But to compute this on large scale is a big challenge because it doesn't scale so well. So we have this project where south of here we have the Harz Mountains. It's a sloped terrain, and if you want to understand what happens in some city if you have a big heavy rain event, you have to look at 400 square meters, 400 square kilometers of area, and you have to do the computation at a resolution about a meter, because if you go much coarser, you're going to miss some culverts and dams, and you'll get completely wrong results. And you can be diligent about this in algorithmics, and I'm not going to talk about how you do this, but when you do this, it's very clear that AI is not the answer, because AI doesn't have the data. And you look at what data we have in terms of precipitation. We have official, in Germany, we have about 600 weather stations that measure precise precipitation. You know the size of Germany. So you get like one every, I don't know, 600 square kilometers and so on. It's completely impossible to run a model, AI model in this and train it on this. And it's also not necessary. But, and now here, magical thinking. I talked to these, all these hydrologists, and basically since November 22, you know what that date means, they stopped talking about computer science and they talk about AI. And you ask them, like, where did you get this high-resolution data? And they said, oh, the AI gave it to me. So it's interpolated. The input data is interpolated by some pattern recognition or some pattern building stuff and so on. And then you talk about, like, this is completely meaningless, but the AI told it to me. So it's really, really magical thinking. I could go on about this. And that's really, so yeah, there's a lot of things you can do with AI, a lot of things where you can speed up with AI. But we really, 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 as scientists in this room, we need to be super mindful, and we have our job cut out not just to look at papers and say, was this written by AI? Does this help me structure the sentences? Am I confronted with reviews written by some large language model? But the science we're doing is not just constructing sentences together. It is being mindful of what these things mean and what the structures are that we have, and we need the appropriate ones. And so the challenge of not just educating the general public, but even our colleagues from neighboring fields, in this case hydrology, has become so much bigger. And that means I saw a lot of, some of you were like nodding like this, and beyond the context of these kind of networks, we really have to work hard on this.
Okay.
I want
Yeah.
you give me a general question.
Yeah, it's fully okay. Yeah. You want to say something or?
Yes, so in our field, I mean mainly physical layer of communication, so most of the things are model driven, but of course there could be some rooms for AI. For instance, sometimes we talk about systems like integrated communication and sensing when we think of, for instance, having some radar sensing. But actually, sometimes we can also think out of the box. So thinking, for instance, we can do the sensing using maybe camera visions, and then once we, I mean, we don't need to stick always to what have been already done in the, I don't know, last 5 decades. Sometimes we can find new solutions and new applications. Since nowadays, maybe everywhere there is a camera, then some part of the communications may not be needed anymore. And especially you can then, by having new tools, you can think of new solutions. So maybe in these areas, AI could be more helpful.
Okay,
Okay.
if I may say something regarding this, I mean, a dual problem is that wireless researchers are starting to look at is the impact of AI on the wireless communication infrastructure, in the sense that now, I mean, it is expected that in the future AI agents will generate a lot of traffic, lot of uplink traffic. So I mean, there was recently a white paper by Nokia that was just addressing this fact. I mean, that it's expected a new rise in the traffic related to AI agents, and also the need for more computing power at the edge. So probably, I mean, we don't know what's going to happen, but it could be that if things go as, I mean, people think it will go, there will be, a novel transformation of the network is needed in order to be able to accommodate, to support the growth of AI in wireless infrastructure. So that's one thing related to AI.
Okay.
So there is a lot of quantum AI in the literature, so but I will try to skip that. So the traffic is a big problem, and the explosion of control traffic, not only at the wireless but also for the management and the data analytics. So if you have service function chains that are virtual network functions that become agents, then you have to train these agents. You have to monitor the network in real time to train these agents. And this is one aspect. Also where you compute them, edge, cloud. This is also, so the computational problem is also a big challenge. And this means investments not only in the data rates or in the links, but also in the edge computing infrastructure and cloud computing infrastructure. And also, I was in this talk in Globecom, I attended it as well.
You know what I'm talking about, yeah.
So practically there is AI everywhere, and not only AI in general, but LLMs. Now they are starting talking to place LLMs everywhere. So this means how can you monitor that? So imagine that you have your network without network engineers, because all these agents do everything. If there is a line of code that goes in one agent that you don't want, or there is a poison in the training data that you don't want, how can you realize that in a network of millions of nodes and billions of agents? So this how this becomes like a full line.
Yes.
So, and it's unmanageable. So AI everywhere means that you don't know anymore your network, in my opinion.
Yeah, I'm also skeptical, I have to admit. Yeah, Bulat. Yeah.
All right, I'm going to actually combine the two topics that, Mark, you had suggested. How do we, both as researchers and I guess the question is to practitioners like Mark and the person with all the videos, how do we protect ourselves against what I would call AI trash? And it's not trash in a conventional sense. It's not rubbish. It's the impact of AI companies clogging the traffic on the networks, clogging, my wife's social media page with AI-generated photos, preventing me from accessing my favorite news sites because the AI bots are busy trying to post stupid comments, trying to get other people, real people, to respond to them. That kind of rubbish, how do we actually deal with it in this new world? I mean, back when newspapers were invented and promulgated in 17 and 1800s. 1800s was the kind of mass printing of newspapers. There's actually a picture of all of the newspapers discarded on New York subway by business people who would go to work and just leave them there. And that drove the first environmental movement in my country, in the US. We need an environmental movement to counteract the pollution, not just carbon. Carbon is the least of my worries. I mean, I'm going to be long dead by the time that our Earth is destroyed by our carbon emissions. I care about now, and the fact that the AI trash is actually affecting my life in a negative way.
So how do you differentiate good news from bad news, or created news, so facts from non-facts? Yeah, I mean, first you have to differentiate. Yeah, you get spammed. Any answer to that? Yeah, no, I reflect that. It's a hard stop at 24. Yeah. Any comment on that? Yeah. Okay.
I think I was explicitly mentioned as the video person or something like this, right? So there are three aspects that I sort of extract from what you were saying. The first one was about network, and I will not answer to that because I'm not a network person, and there's other very competent people here in this room. The second one is judging the AI itself. But then there's a third one, and I would keep the second relatively short and then say something about the third. So we are faced with another transition here, which is something that has happened often in human technology and history and development, which is a decoupling between certain aspects. So we had all these technological transitions, like looking for food every time we get hungry on a daily basis. So when we're transitioning from hunter-gatherers to an agricultural society, that was the agricultural revolution, and you could decouple this searching for food every day from longer term doing other things and then basis for specialization and so on. We also had this decoupling from manual human labor to machines, industrial revolution. And then that has some effects where all of a sudden you can afford not to have slaves anymore, and maybe there's a feedback between this and so on. And so what what we're witnessing now is this decoupling between external shape, external appearance of something, of text, and internal meaning. So we're really used to judging the competence of a writer by looking at what does the text look like. And we've been doing this, I mean, when we're grading papers or reviewing papers, we've been doing this forever. And this is a point where we're getting efficient, we're developing filters along the lines of Daniel Kahneman's thinking fast and slow. So we have these filters where we look at this and say, like, that makes no sense, that's a bad paper. By just looking at how it's written, it doesn't have this appearance, right? So I could say more, I promise to keep that short. Now that gets me to the last part, which is, what is the whole objective of doing all these things? And when you look at AI slop, and you were referencing social networks, in a sense, yeah, AI is a really big challenge, but there's another one, which is human attention and human focus. And I would greatly recommend looking at this, what that does, because our own focus and attention and role as scientists, like thinking about what we're doing, that is also getting sloppy. Independent of AI, AI is just making it worse, because our work and our focus and what we're looking at is being mined, is being fracked in a way that is, what you're describing is only compounded by the AI. That is getting so unbearable. But even before, even when it comes to algorithms in the sense of like just choosing contacts for you and so on, this is a very, very serious problem which goes beyond large language models, which is what's happening with our brains, our minds. And there's some discussions we should continue here. But this third part, human attention and human processing, that needs to be considered independently. So that's trying to address what you were saying on 3 different levels, like the network, what it does, the AI slop, but also the main focus, I think, is then what it does to us. And we could continue this for an hour, I think, but we shouldn't. We can follow up.
Exactly. I think we have to stop, so you're getting more active here on my side. I thank you very much for having this panel with me.